Hello, Assalamu alaikum.
Hello.
Hello, Abdullah, can you hear me?
Yeah, I can hear you. Can you hear me?
Your voice is very low. If you can speak a bit louder.
Can you hear me now?
Yes. But it's not that much clear.
Better now?
Yes, better. Okay, so how are you? Are you good?
I'm good. What about you?
Okay, so we are going to start with the very basic things. So first of all, what is population?
Number of people in the city?
Number of people in the
City?
study.
City. City.
City. Why city? Is it specifically city?
No, doesn't have to be a city. Anywhere.
Anywhere. So population means collection of all items. It is necessary that they are people. It can be items, it can be computers, it can be trees, it can be animals, it can be anything. So we can say collection of all kind of items, everything is called population. Okay. So what is population? For example, give me some examples of population. All trees, if we consider trees. All students in a particular university. All people living in Pakistan. Any item, anything, any condition, anything that is collection of everything, each and everything comes, and that is called a population.
Okay.
So it is all collection of all those items for which we need the information, for which we need information, or we can say which are under consideration. Under consideration means for which we need information or for which we require the information. Now, the second term used is going to be what is data or what is sample. Let's come to sample first. Okay, what is sample?
The part of the
The part of the
population?
population. So sample is subset of population. Subset of population. It means what is population? It is collection of all the items. But what is sample? We have taken a small unit from the population to which we are going to examine in order to get information about the data. So what is population? That is collection of all the items for which we need information. But what is sample? That is a subset of population. That is a small unit taken from population in order to gather the data. Gather the information or data. So now can you get it? What is population and what is sample? Population is collection of all the items, like every item is going to come in the population for which we need the information. And sample is a subset of the population. We have to take a very small unit from the population, and that is called a sample. Next definition is what is data?
Gathered information.
Gathered information. So very good. All gathered information is called data. Data comes from the characteristic measured on individuals or units. So whatever units we have taken, for example, whatever items we have taken for the population, the information about those items or the information about those units or individuals is known as data. Okay. So now you get the three definitions. What is information? What is population? What is sample? And what is data? Can you tell me what is statistics?
Uh, wait. The obtaining the gathered information, analyzing it.
Very good. First of all, obtaining information. The first step in statistic is obtaining the information. This is the first step. What is the second step?
Summarizing it.
Organizing it.
Organizing.
Good. What is the third step?
Summarizing.
Summarizing. And then after summarizing all of the information, we definitely need to present that information in some form. So presentation of the information, and in last, we have to figure out some analysis from that information. So analyzing the information. So it is obtaining, organizing, summarizing, presenting, and analyzing the information. So what is statistics? Statistics is obtaining, organizing, summarizing, presenting, and analyzing of the information. So up till now, is there any question?
Nope.
Okay. Now we have just read about data, that what is data. So there are two types of data, two very broader types of data. What are those?
Quantitative.
One is quantitative, and one is qualitative. Okay, now what is qualitative data? Let's come to qualitative first.
Qualitative.
Because the qualitative, the word quality means it is related to some qualities. So it means we can't count them. Can we count the qualities?
Nope.
So we can't count them. For example, what is the gender? Can we count the gender? No. But this is
No.
the data. There are 4 females. There are some females and there are some males. This is the data, but we can't count this data. So the data that is uncountable is called, we cannot count the data, that is called qualitative data. So gender is a qualitative data. For example, why are you taking the stats course? What is the reason for taking the stats course? Because this is compulsory. So what is your reason? Is this can you count your reasons? No. This is the
No.
qualitative data. So for example, what is your eye color? Color can be red, green, blue, black. What is the color? Color is a qualitative data. So anything that we cannot count is called qualitative data. And anything that we can count, for example, 100 words. For example, 5 students in the class.
Anything that has numbers, it's quantitative.
Quantitative data, very good. So now
Non-numbers is qualitative.
yes. So now just let's read the definitions for one time to figure out if there is no confusion. Okay. So what is statistics? Statistics is a set of methods for obtaining, organizing, summarizing, presenting, and analysis of the data. So we have to do these 5 parts and then we get the statistics. So now what is data? Our data comes from the characteristics measured on individuals or units. So whatever individuals or units we take, we gather the information about them, and that is called the data. These can be people, animals, places, things, etc. This can be anything like trees, like animals, like peoples, like computers, like laptops, anything. What is population? Population is totality of the individuals. So total all collection, all items, I write all items, collection of all items is called population, for which we have to get the information. Okay. There are 2 broad classifications of the data. Is the, no, this is moving. Yes, we have to do 1, 2 here first. Okay. What is sample? Sample is a subset of the units in a population that we actually examine in order to gather the information. 1,000 votes, okay, are asked which candidate to support in the upcoming election. So this is the sample. We have to check the 1,000 voters. That for which are they, whom are they giving the votes? 50 arthritis patients are given a new treatment. So can we give a new treatment to all of the population? No, we are going to
No.
take 50 people from the population, and that 50 people is a sample, and we are giving them the new treatment. 20,000 televisions in the US are monitored or for Nielsen ratings. So for Nielsen ratings, we can't monitor every television that is available in US. So every television in the US is a population, but when we take 20,000 televisions from all of the televisions, that is the sample. So are you getting clear that what is sample?
Yeah.
Okay.
A small
So
part
now
of the
what is the
population.
population in each of these cases? I have already told. Okay. Now tell me again, 1,000 voters. What is the population? This is the
Sample.
sample. What is the
The
population?
sample. The
All voters?
all voters, yeah.
Okay. 50 arthritis patients. What is the population?
All of the patients.
All arthritis patients. Very good.
All the time.
20,000 televisions. What is the population?
All the televisions.
All televisions. Good. So are you getting it?
Yeah.
Okay. After U1, 2, we need to move to U1, 3. This is 4, this is 5, and then we have 6. What is this happening? 7.
I think 3 is on the top.
Yes. I think 1 is missing. U1, 3 is missing.
I think it's up there, maybe.
Oh, yes, it's up there.
There.
Okay. So a variable. Now, what is a variable? A variable is a characteristics or property of an individual. So now we know what are individuals or what are, so the characteristic, any characteristics or any property that individual have is called a variable. For example, time until a light bulb burns out. So light bulb has a property of time. Heart rate of smokers versus non-smokers. So the heart rate of smokers is different from the non-smokers. So this is the variable. What is a variable? Heart rate. Variable is something related to someone. That heart rate is related to smokers and non-smokers differently. So heart rate is a variable. Number of heads in 5 process of a quarter. Hair color is a variable. Your grade in this course. So if you score A in this course, what is A? That is a variable. So what is variable? Any characteristics or property of anything. So for example, the property for this course or the characteristic for this course is grading. So grade is the variable. So are we getting what is variable?
Mm-hmm.
Can I move on?
Yeah.
Okay. Now I just told you that there are 2 types of data. So now we are going to study what are those 2 types, categorical data or qualitative data. There are 2 broad classifications of data. Categorical data represents values of categorical variables are called qualitative variables. So you can also name qualitative data as categorical data. This is the one name, 2 names for the one single thing. So
Okay.
gender, gender is a quality. Reasons for taking the course is a quality. Your favorite show, TV show is a quality, and eye color is a quality. Can you mention
Yeah.
one more quality? Qualitative data?
Car brands.
Very good. Okay. So the next one is, in some cases, there is a logical ordering of to the values of a categorical data. So we again have a categorical data, but now the categorical data is not simple. It has some ordering. Ordering means from first, second, third, fourth, there is some ordering. So for example, placing in a hockey tournament. So in a hockey tournament, when everyone is placed somewhere, obviously this is a categorical or qualitative data, but they can be placed like first, second, third, fourth. Service rating at a restaurant. So service rating is a quality. To rate a service is a quality, but the service has types. It can be good, it can be fair, it can be poor. So grading is a quality, but grading has type from A plus to F. So if ordering makes sense for the values of a categorical variable, it is called categorical or ordinal. Otherwise, it is called categorical or nominal, like all variables on the previous slide. Okay. So now there are 2 more. So we have data Data has two branches. One comes categorical. Now, categorical again has two branches. What are the two branches?
Category is
Ordinal.
qualitative, right?
Yes, categorical and qualitative is one and the same thing.
Okay.
Okay. So it has again two types, ordinal or nominal. So what is ordinal? The name represents order. So when we can order something, like when we can put something in order, like first, second, third, fourth, like first floor, ground floor, first floor, second floor, third floor, something like this, and we can order something, then that is called ordinal data. And if there are things that cannot be ordered, then that is called nominal data. Okay.
Okay.
Okay. So now tell me, how many types of data are there?
Categorical and
Quantitative.
qualitative.
Other is quantitative. Okay. So categorical has how many
Quantitative.
types?
Ordinal and
Nominal.
nominal.
Good. So what is the meaning of ordinal?
In order.
In order, that we can place the information in order. And what is the nominal? That we cannot place the information in order. Okay.
Okay.
Now the next is quantitative data that is left to study. Quantitative data represents the values of quantitative variables. For example, for which arithmetic operations such as addition and for any operations like this mean numbers, when we involve the numbers, that is called quantitative. Quantitative word comes from quantity, and quantity word comes from something that can be measured. So final exam score. The score of the final exams, like you scored 65. So this is a quantitative data. Your height is 5.6 is a quantitative data. Volume of air in the balloon is 2. So it is quantitative data. So any measurable thing is called quantitative data. So
Okay.
any kind of confusion up till now?
No.
Confirm?
Yeah.
Okay, classification data type. Again, there is a chart as we have made the chart before. There are two types of data. Do the data that take numerical values for which arithmetic operations make sense. So the data for which arithmetic operations make sense is called quantitative data. The data for which arithmetic operations make sense, what is called? Tell me, this is the question.
Quantitative.
Quantitative. Why it is called quantitative?
The numerical values.
Very good. And that cannot take numerical operations is called?
Qualitative.
Okay, qualitative further have two types. What are those?
Nominal and cardinal.
Nominal,
Ordinal and nominal.
ordinal and nominal. So what is the meaning of ordinal?
In order, and nominal not in order.
Not in order. Very good, excellent. Okay. State whether each of the following variables are in quantitative, categorical and nominal, categorical and ordinal. Okay. So political party you support.
Categorical.
Categorical. Which type of categorical?
Nominal.
Nominal. Speed of passing a vehicle.
Qualitative. Quantitative.
Sorry?
Quantitative.
Quantitative. So we can measure the speed of the vehicle. So month of the birth.
Qualitative. Categorical. Ordinal.
Ordinal. Very good. Why ordinal?
Because it's in order.
In
Months.
order. Months are in order. Very good.
I have a question.
Yes.
Since months they don't come in numbers.
If it says number of months, then it is quantitative. But it's saying which month did your birthday come? So it's simply which month your birthday come, by the way.
Again?
You forget the month of birth.
May. Sorry. 5.
May.
I didn't hear a
Okay.
question.
So it's just May, and we can put in order it is the 5th month.
Hmm.
So therefore it is categorical. But if it says how many something how many months are there or how many days are there, then it's going to be the quantitative one.
Okay.
Is everything going clear?
Mm-hmm. Yes.
Okay, so up till now we have learned about the types of data, definition of statistics, types of data, and all these things. So let's do a few practice questions and then we will move on to the next topic.
All right.
Okay. Can you read the first question? Use the following information. Okay, start reading it.
Use the following information to answer the next 5 exercises. Studies are often done by pharmaceutical companies to determine the effectiveness of a treatment program. Suppose that a new AIDS antibody drug is currently under study. It is given to patients once the AIDS symptoms have revealed themselves. Of interest is the average mean length of time in months patients live once they start the treatment. Two researchers each follow a different set of 40 patients with AIDS from the start of treatment until their deaths. The following data in months are collected.
So they have
Andrew,
collected the data in the months, status of researcher A, this is the data, and researcher B, this is the data. So determine what are the key terms that were in the example for researcher A. So what is the population for researcher A?
40,
Sorry, population.
40.
No.
Could you go back up?
Sorry?
Could
Yes,
you go back up again?
yes, I can go. So what is the population?
Those are 40 patients. It says 40 patients with AIDS.
Yes, but this is not the population.
All population?
All AIDS patient.
All AIDS patient, yeah.
So what is population?
All AIDS patient and sample is 40.
All AIDS patient, because they consider all AIDS patient. Then they took a subset of from all AIDS patient, that is 48 patients, and that is a sample.
Mm-hmm.
So all AIDS patient is population, 48 patient is sample. The third question, parameter.
What's the parameter?
What's the parameter? Okay. Suppose that the new AIDS antibody drug is currently under study. It is given to the patients when the AIDS symptoms have revealed themselves. Okay. Of interest is the average mean length of the time in months patient live once they start the treatment. So what are they talking about, or what is the objective that is called the parameter? So two researchers follow a research time for the 40 patients and they give their. So what is their main objective or main thing of interest? That is average mean time, the average length of time in months patient live for the start of the treatments. So this is called the parameter. What is parameter? Average length of time the patient live for the
Average. So average is parameter.
average length of time. This is called
And
parameter.
so
Now, what is
anything
called
average is parameter?
statistics? Sorry, your voice is not
Anything
clear.
anything average is parameter?
Not averages, anything which is the objective or which is of our
Okay.
interest. Like they're saying of interest is, why are they doing all this problem? Because they need to find out the average mean length of time the patient live once they start the treatment. So what is the main
Okay.
objective is, that is called parameter. So
Got it.
okay, now if that objective have some, like if they write average mean length of time and they write 2 hours, so that 2 hours is going to be the statistic. The interest written is called the parameter and the numerical value of that interest is called the statistics. But in here, if it is no specific months written, so we can say statistic is number of months. Okay.
Okay.
Okay. What is the last question? It is variable. So what is
Variable.
variable?
Um,
Variable is
8.
again length of time. For example, x is equal to length of time. So basically, the three things are very interrelated. Parameter, statistics, and variable. What is parameter? The objective. The numerical value of objective is statistics if it is given. Otherwise, it will remain same. And what is variable? What we need to find out. So obviously, what is objective is the same thing we need to find out. So
Okay.
these things are
So
too much
parameter
related.
and
Okay?
variable almost same.
Almost same, yes, almost same. So what is the population here? All AIDS patient. The sample is 48 patient. What is the parameter? Average length of time 8 patients live after treatment. What is
Statistic.
statistics? It's the
Month.
number of months that 8 patients live after the treatment. What is the variable? Length of time 8 patients live after the treatment. Should I move on?
Yeah.
Everything is clear? You can
Yes.
take the picture of the question and you can do it afterwards. You can revise it.
Okay. Is it possible to send the recordings?
Yes, I can.
You can send it to me after the class.
Okay, great.
Next question.
Okay. Number of times per week is what type of data?
Number of times per week is what type of data? Qualitative. No, sorry. Quantitative.
Quantitative. Okay, now quantitative also have two types. If
Hmm.
quantitative data, we just read one time, but I'm telling you about the second type. Quantitative data, if it is like integers, 1, 2, 3, 4, like this. So it is called discrete. And if it is in decimals like 0.5, 0.25, then it is called continuous. Okay. Quantitative
Okay.
also have two types. If it is the specific numbers, then it's discrete. If it is not numbers, decimals, then it is called continuous. So number of times per week can be, number of times
Discrete.
can be like 2 times, 3 times, 4 times, like, so it can be discrete.
Yeah.
Got it?
Mm-hmm.
Okay. So this is what we have done. Now we are coming to, okay, question number 8. Duration, amount of time is what type of data?
Amount of time. Amount of
Duration of
quantitative.
something like from 2 to 3 a.m. Duration of time.
Quantitative.
Quantitative. Okay, which quantitative?
This continuous.
Continuous, good. The colors of the houses around the park are what kind of data?
Qualitative.
Qualitative. Okay. Okay, now this is the population of the total number of deaths worldwide as a result of the earthquake from 2000 to 2012. So this is some data given, and this data is related about the population of the world from 2000 to 2012. Okay, so the question number 1 is, what is the proportion of deaths from 2007 to 2012?
Total number.
2007. They're asking what is the proportion of deaths from 2007. So we have to
Hmm.
from 2007 to 2012. We have to move to 2012. So it means we're going to add from 2007 to 2012 and we will get
Yeah.
our answer. So if you have a calculator, you can add it fastly and let me know.
Yeah, I'll add it. Adding.
So are you adding?
Yeah. 433,354 without the zeros.
Okay. What percentage of death occurs before 2001? So before 2001, what percentage of deaths occurred? So total number of deaths in 2000 are 231 and 2001 are, so before 2001, it means we are only going to consider 2000. Before 2001 is only 2000, right? So it's 231. How to find the percentage? 231 divided by total number of deaths, that is 823,856 multiply by 100. This is the way we find the population,
Yeah.
percentage, sorry. So we have
Yeah.
to find how many percentage of deaths occurred before 2001. So can you tell me after finding it?
Give me a second. 0.02.
It's 0.02 or 0.3. Is it?
If you round it, then 3, yeah,
Yes.
0.03.
So you will get 0.03%. Okay, good. Okay, for the first question, what was the answer? A part. What is the proportion of deaths between 2007
It was
and 2000?
400, 433,354.
Okay,
433,354.
okay. So the third question is, what is the percentage of deaths that occur in 2003 or after 2010? Okay. What is the percentage of deaths that occurred in 2003? So in 2003 is this box. I'm just making a box over here. So in 2003, what is the percentage of death that occurs in 2003? Okay. Or after 2010. After 2010 are these two boxes. So how you're going to find the percentage now? It means you will add them first. 33,819 plus 21,953 plus 768. And then you will divide it by total 823,856 and then multiply by 100. Okay, tell me what did you get?
Sorry. 6.9%.
6.9%. Good. We have done till C part. Okay. D part is, what is the fraction of deaths that happened before 2012? Okay. How can you find the fraction of deaths that happened before 2012?
Before 2012. Okay, so all of them.
Sorry?
Before 2012.
So you have to find the fraction of death that happened before 2012. So it means all of these deaths happened before 2012.
Yeah.
So it means instead of adding them all, can we subtract
Just
total
minus,
from
yeah.
this? Yes. Okay, tell me what you get.
823,088.
Very good. 823,088 and divided by, because we have to find the fraction, so divided by total 823,856. So this is the answer. We need to give the answer in fraction. What kind of data is the number of deaths? Okay. So what kind of data is number of deaths?
What kind of data is the number of deaths?
It's qualitative or quantitative?
Qualitative.
Qualitative or quantitative?
Qu quant
Yes, quantity.
Quantitative.
Quantity is given, na? Every
Yeah,
equal
quantity.
quantity. Okay. Now quantitative, it is discrete quantitative or continuous?
Discrete.
Discrete, very good. Because deaths cannot be in points. We cannot say that 0.5% died. It's 1 or 2. It cannot be in decimals. It cannot be in fractions, okay? Now, next is earthquake, part F, yes. Earthquakes are quantified according to the amount of energy they produce. What type of data is this? Okay. Earthquakes are quantified according to the amount of energy they produce. So earthquakes produce the amount of energy like 2.1, 5.0, 6.7. So what type of data is this? First of all, qualitative or
Discrete.
quantitative?
Quantity.
Very good. Now
Quantity.
which? Discrete or
Discrete.
continuous?
Discrete.
Check it carefully.
Discrete.
No.
Uh, at first.
When
Ah,
because
yeah, continuous. So
continuous. Why continuous?
that that's two decimal.
Decimals. The examples are clearly saying it because it is given in decimals. What contributed to large number of deaths in 2010?
One
What
contributed.
contributed to the large number of deaths in 2010 in 2004? Explain. Okay,
Large
what
earthquakes.
contributed to the large number of deaths in 2010 and 2004 due to earthquake? This is for part G. Are all of these questions clear? This was a very good exercise.
Yeah. Yeah. There.
Okay, read this question, question 42. For each of the following gate exercises, identify. Okay, so we have to restart the meeting in 1 minute. So let's restart the meeting and then start it again. Okay. So for each of the following 8 exercises, identify the population, sample, parameter, statistics, variable of the data. Given examples very appropriate. Okay. So for question number 42, a fitness center is interested in the mean amount of time a client exercises in the center each week.
Um. Statistic.
What statistic?
I have to answer, right?
Yes.
Oh
So
wait, I have to
how
label
much
all of
time?
them. The amount of time, yeah, statistic.
Okay. Sky resorts are interested in the mean age that children take their first sky and snowboard lessons. They need this information to plan their sky classes optimally. Okay, so for 43, tell me A, what is population?
Children, all children.
All children, very good. So all children who take sky are called is population. All children who take sky. Okay, B part. Tell me what is the sample?
Children.
A group of this.
Mean age group of children.
Okay, what is C part? Parameter. Parameter.
The group of children.
Not group of children, mean age of children, because they are interested in mean age. So the thing we are interested in is called the parameter. So mean age of children who took their first snowboard lessons.
Could you explain again what was parameter?
Parameter is the thing we are interested in.
Okay.
Let's read the question again. Sky resorts are interested in the mean age that children take their first sky and snowboard lessons. So interested in whatever thing they're interested in is mean age that children take their sky and first, so this is called parameter. The thing that question interested in. Okay, parameter is done. Next is statistic. So this will be remain same. The mean age of children who took their first snowboard lessons. The next is variable. We will write for the variable, what we are going to do is E part variable. We will write X is equal to mean age of children. We will write X as a variable. Mean age of children who took their first snowboard lessons. And what is F? The data. What is data?
Children.
Number of children, values of X. Whatever value this X has, the variable has. So again, let us understand this question. All children who take the snowboard lessons are population. A group of children who take the snowboard lessons is the sample. Mean age of the children, the thing we are interested in is parameter, and number of thing that we are interested in is called statistic that we can donate by X. It's called statistics. Variable is X and number of values of the X is called the last one, that is data.
Okay.
Come to question number 44. A categorical, no. A cardiologist is interested in the mean recovery period of her patients who have had heart attacks. Okay. So number A, population.
All patients.
All patients, good. Number B, sample.
Her patients.
Heart patients, very good. Number C, what was C? Parameter.
Parameter. Have had heart attacks.
Mean recovery period.
Mean recovery.
Mean recovery period. Okay, this is statistics. This is parameter. What is statistics? Number of time interval for the mean recovery period. And what is variable? X is equal to mean recovery period of her patients. And what is data? Number of patients. Are you getting it? This is easy.
Could you explain the X again?
Yes, X is a variable.
Yeah.
So what is variable? X. What is X? Number of patients. to get mean recovery? And how many number of patients are there? That is data. Okay.
Mhm.
Got it? Can I move on?
Yes.
Insurance companies are interested in the mean health cost each year of their clients so that they can determine the cost of health insurance. What is population for 45?
Uh, population is all clients.
All clients of the insurance company. Okay. What is sample?
Their clients.
Sorry?
Their
Of clients.
clients.
Yes, group of clients. Okay, number C. What is the C was parameter? What is parameter?
Health cost
Now
for
you
each
have to
year.
tell me the parameter. Yes.
Cost each year.
Mean health cost each year. So they're interested in
Mhm.
mean health cost each year. So whatever they're interested in is called the parameter. And once you get the parameter, you will get all the three because they're all similar.
Mm.
Mean health cost each year. So now what is statistics?
Uh, each year.
Mean health cost of the samples each year. And what is variable?
X.
X is equal to mean health cost of any one client. Mean health cost of one client. And what is data? Values of
Um,
X. Whatever the values of X are is called data. We don't know what are those values, but whatever the values of X are is called data.
mm.
Okay. Come to 46. A politician is interested in the proportion of voters in his district who think he is doing a good job. Population.
Vote all voters.
All voters. Very good. B. Sample.
His voters.
Voters interested in the district.
And
C.
yeah.
Parameter.
Doing a good job.
Proportion of voters in his district. The thing you have to check interested in. After interested in, you will get the very first point after interested in will represent a parameter.
Okay.
Okay, statistics, number of the proportion of voters that were interested in the district.
Mm-hmm.
Okay, and whatever the that number is called data. 47. A marriage counselor is interested in the proportion of clients she counsels who stay married.
All clients.
All clients, good. Population is all clients. B, sample.
Group of clients.
Group of clients of the marriage counselor. Very good. Third, parameter.
Proportion of clients.
Who stay married. Proportion of clients who stay married. Okay. The next is statistics.
Number of proportion. Number of uh,
Proportion of
clients who stay
sample of the
married.
clients. Okay. And variable.
X.
X is a
Each triple
variable that
that.
is number of proportion of clients. What is data? Data is important for this question. 47.
That who stay married. Number of besides stay married?
No, data will be yes or no. Let's read the question again. A marriage counselor is interested in the proportion of clients she counsels who stay married. So it means what is she trying to figure out? How many of the clients that she counselor gets stayed married? So either the client stay married, yes, or either the client does not stay married, no. So data has only two options, either yes or no. Either the client do stay married, either the client does not stay married. Okay.
Okay.
So data has two options. Political pollsters may be interested in the proportion of people who will vote for a particular case, 48.
All people?
All political pollsters may be interested in the proportion of people. Yes, all people is population sample. Proportion of people for the interested for the vote is the sample. Now
Yeah.
tell me what is parameter.
Proportion of people?
Yes. Proportion of people next who will vote for a particular case. All of this statement will come in the line of the parameter.
Okay.
What is data?
Number of.
Either they will vote or they will not vote. Yes or no.
So just write yes or no for
Yes.
data?
Yes. Because there is no number of things that there are two,
Okay.
there are five, or there are 10. They said either they will vote or either they will not vote. They need to find out the number of people who, proportion of people who will vote for a particular case or not. So either yes or either no.
Okay.
A marketing company is interested in the proportion of people who will buy a particular product. Okay. The last one, 49. Okay, A part. Population, all people. What is sample? Group of people.
People. Group of people.
C part.
Proportion of people who will buy a
Parameter.
particular product.
Yes, proportion of all people who will buy the particular product. D part. Statistics, proportion of the sample of people who will buy the particular product. E part, variable. X is equal to number of people who will buy it. This is a variable. Who buy particular product. F part, data. What is data?
Number of people who buy.
Yes.
What was D again?
D again, what was D? Parameter, what is parameter?
Param-
Parameter is proportion
The
of people who will
statistics.
buy a particular product.
Yeah, the
Statistic is
statistics.
number of,
People who will buy.
yes, number
So
of,
D and E are same.
almost same, yes.
Okay.